here's what I want to go to next. It's this notion of really custom geometries. Now, I think we can sort of introduce this pretty quickly for you. The idea is, when you're going out and looking for custom or pieces of furniture or cabinets or whatever, and you find them in Revit City or you find them in the default Revit library, and you design with them, what happens pretty quickly is everyone's designs start looking the same because you're all using the same couch, you're all using the same cabinetry. And what tends to happen is we as designers, just because we're creatures of trying to minimize the amount of work we do, we use what's available to us. So we drag in all the standard pieces and we sort of build like Lego out of all those things. A lot of people criticize modeling tool like this because people stop losing their creativity. They just start always just assembling blocks, things that are very easy. So the idea is you don't have to do that. That you can actually go through and create your own custom pieces. And we're going to start talking about how you do that. There's ways that we can do that in terms of basically customizing some existing pieces that people have already put in the library and make them more what we like. Or we could actually go through and do something called modeling in place, which is, it's around the notion that I have some specific thing I want to do in this one project. It may not be something that I want to share amongst a whole lot of projects, but I just want to do some very specific one-off thing in this one project. It lets me create it very, very quickly. And what we're going to learn is first how to create those little one-offs and build them up, and then generalize that to sort of, okay, great, if you can handle building it in one project, here's how you build it in a way that is generalizable and shareable amongst all the projects and parametrically controlled. Because really, in the end, you'll be able to create these same sort of objects, these things where you type in values and things stretch and reshape and hug the things. You want to be able to have the ability to do that. So that's where we're going. As we think about that, so modeling in place, the thing that we're going to learn first, is really all about when objects are going to be used exclusively in one project. And a great example of that is countertops. Because countertops, turns out if you really get out in the world, they're almost all unique. Very few countertops are exactly the same length. If it has to sort of hug up to walls and cabinetry, it's a pretty custom thing. It depends on a lot of other things. You sort of build countertops to fit the geometry of what's around it. Okay. Building things as models in place, they're very quick to create. We get a perfect fit. Limitation, though, is they tend not to be reusable. You sort of have them in a single project. I can't just sort of give you my model in place and share it with you so you can put it into your model. Okay. To do that, I'm going to have to convert it into a family that I can send to you. Okay, but it's a good starting point because it's the same basic principle. So we'll start with this. As we're creating custom geometries, the basic rhythm is always like this. We open the Model in Place tool, so we say, hey, we're going to create a new custom object. Okay? We're going to choose some sort of a family category for that, because everything we put in the Revit model has to have some sort of category. It has to know that it's a furniture piece, a casework piece, a wall piece, a plumbing fixture piece. Everything belongs to a category, some part of the hierarchy of the model. So we can turn it on or off or count it or schedule it. Everything has to have a place. We're going to model the thing out of solids or voids. We're going to start learning how you sort of build things up with a lot of little pieces or maybe subtracting pieces away. And we'll start the whole exercise today. We'll go further with it on Thursday. And we're also going to set some properties for it. So what is the material? What's the start and stop? And finally, we're going to finish it. So there's a whole flow there you're going to wrap your head around. And it all starts with this notion of just really choosing a family category. So let's just kind of walk through it together. I'm going to go over here to my level 1. Zoom on in there. And let's see if we can create something that looks interesting with my big fat blue walls. Okay, so I'm going to go out. I'm going to start by just placing some components. I'm going to put a little bit of cabinetry in here. So I'm going to load in some casework. I'm going to put some base cabinets in here. And I'm going to grab some of these 2-door, 2-sink units. So I'm going to put some of these in. I'm going to put them on the wall over here. Actually, I have a very big space here. I'm going to put that one on the wall. I'm going to put that one on the wall. I'm not going to put that one on the wall. I'll put that in the wall in a second. I'm going to put some out there in the middle of the room, too. I'm going to create an island. Yeah, these components that are over here, they're not looking too off like that. Actually, I'm just gonna have to make those walls thinner on. It's gonna drive me crazy. Let me put you up against the wall. This next one, I'll push it up against the wall. The nice thing about components is you can use the align tool to kind of make things look perfect. Align, I'll just take that into that cabinet and take that one and put it to it. I might lock them together. That way, if I move them, they'll all move together as a big unit. Okay, so just to sort of assess up where we are right now, let me zoom on in there. Okay. So I got a couple of kitchen cabinets up against the back wall. I have something over here that's going to be our island in just a second. So far, so good? Okay, you probably did something like this in your house. So we got some cabinets in there. We're looking good. We want to put a countertop on this. So what I'm going to do is go back to that level 1. Countertop, if I can't find exactly what I want, I'm going to try just making one from scratch. And how I'm going to do that is, as opposed to loading a component, I'll go to the Architecture tab, choose Component, and say, let's model something in place. Again, we're going to create something that's unique to this project. First thing it always asks is, okay, you're going to create something. What category do you want to belong to? So I'll say, let's put it in casework. Okay. Give it a name. It's going to be my kitchen counter. Okay. We're ready to start creating. In terms of creating, we have several different tools available to us. We have extrusion, blending, sweeping, revolving, and swept blend. We'll talk about all those variations. But extrusion is probably the easiest one to understand as a starting point. Because a lot of things in life can be modeled by extruding them. Extrusion is the idea, we're going to draw some sort of profile on a plane, and we're just going to give it a third dimension by extruding it, pulling it perpendicular to the plane, a set thickness. Okay, so a lot of things are that. If you're going to model this lectern, you know, this countertop right here, this is kind of a rectangle that just got extruded to make it fat. Okay, if you look at this countertop that you're working on right now, you can sort of picture how you could draw the rectangle and sort of extrude it up. A lot of things are extrusions. It's sort of one of the simplest ways to create geometry. Even for this flat panel, I could go through and draw a big rectangle on the wall, then pull it out 2 or 3 inches and give it some thickness. Maybe cut a hole in it and do another extrusion for the piece of glass, something like that. So we can build things up as a series of different pieces. And when we are extruding things, what we're going to do is we draw some sort of boundary. Okay? We have to go through and make it a complete boundary. All the boundary tools sort of work. So it has to be a continuous loop. That we're pretty good at. We can use offsets. We'll show you how to do that. If we do any interior loop, they'll cut a hole. They actually sound familiar, like floors and everything else. And we're going to do some things about saying when and where to stop it and give it a material. So let's show you what that looks like. So here I am, I'm back over my model. I'm going to say, let's create an extrusion. It's going to be a solid, so we're going to create some positive versus a void, which would be negative. Okay. I can draw some lines, so at a real quick level, I could just sort of draw a boundary like this. That would be a countertop for that back piece. Now, as you're designing, let me take that one out. You might want to actually use some picks and offsets to give you a little more control. What I actually tend to do is I'll draw that back line. Countertops can have a funny property. What they tend to do is actually follow the edge of the cabinets. And you give about like an inch overhang, so a little bit of overhang around the outside. So if I want to model that, another way to do that is to sort of say an offset of 0,1 and just pick the edges. This is a way just to get a little bit of overhang. Let me see if I can zoom on in there. So the back wall, I'm kind of actually keeping right up against the back wall, but I'm putting a little bit of overhang on the front edges. Okay. Now, I need to make that a continuous loop, so I'm going to trim. So I'm trimming those edges all together. Beautiful. We are ready to go ahead and make this into a countertop. we need to go through and give it an extrusion start and an extrusion end. Let's talk about that. So really relative to level 1, like where does it want to start and where does it want to end? So in the US anyway, our standard height for countertops is 36 inches, so 3 feet. Okay? And most countertops are about 1.5 inches thick. So they go from about 2 foot 10 and a half to 3 feet. So we have that little window in there. So to give it a thickness, I'll say the end is 3 foot 0. The start is 2 foot 10.5. So that gives them 1.5 inches in there. Okay, that just gives it the right thickness. We can also go through and choose a material. And we're going to again talk about materials a whole lot more in the next few sessions. Where if I choose the materials, you can go to the library and see what they have. If you want concrete countertops there. I'm going to put something they have built in there called laminate. Laminate's Formica, if you're used to that term and that brand name. It's sort of a very cheap material. It's sort of thin veneer material. I could add other things to be granite or stainless steel or much more luxurious materials. I'm just going to give it a material for now. You'll spot. I'll say OK to that. So that's enough information. With this information, we can define that countertop. Okay, so if I go through and say, let's finish the extrusion right now and go back to 3D, you'll see that thing actually has a countertop on it right now. Okay, so let's stop there for a second. So in general, the idea of making a boundary and just kind of stretching it in that third dimension, that feel kind of okay? Any questions about that to get started? Because that's the basis for about 4 other things. So let's see. How does that feel? Good? Okay. Let's gonna give you a little more power then. I can choose that thing, and it's an extrusion. I can edit it. And now, let me do it in a floor plan. It'll be easier to see. There's the boundary. If I want to put a hole in it, for example, what I can do is put another interior loop. That's a hole in my countertop. If you have a custom size sink that's in a custom location, you can just trace the boundary around that sink and cut a hole in the countertop where you want it to be. And so that's anywhere you want to put holes, just go through and draw an interior loop. Now, this big old rectangular countertop, this isn't so interesting. Let me go ahead and I'll put a countertop on this piece over here also. But this one I want to be a little more adventurous with. I'm going to put like a big island countertop over the top of this thing. Now, as a big old kind of rectangular island, that's okay. Let me actually give it a little more overhang on the front so we can put some bar stools there. Yeah, okay, but not too glamorous. If I want to be a little more adventurous design-wise, I could maybe... So I've taken out that front line because I want to put a more adventurous front profile on that. I could put on, like a nice arc curve if I want to, just going from here to here. That would be sort of a nice big sweeping arc, maybe you'd like that. If you really want to get groovy about this, maybe instead of just that simple arc, you can put some sort of interesting spline on it. That would be... whatever it is. Just got to make it some interesting space-age Jetsons shape. Okay. The only rule is it has to be a nice continuous loop. I think it's a continuous loop. I'll tell you in a second if it is or not. So I've created a second piece of countertop right there. We finished that, and it did. So let's take a look at that in 3D. Okay. So you can go through and change and reshape and just really start tracing any profile to make arcs, swoops, anything you want. Yeah. That's how you get started. One other piece to this, I can show you that these things actually have little shape handles. See those little blue handles? Those let me just, I don't even have to edit the sketch. I can just stretch and pull, and that actually works with a lot of the library objects. If you choose an object and you see those little stretch and pull handles, you can kind of reshape that way. A lot of the countertops that are built in by default do have that, so you can actually just push and pull in on those handles to real quickly reshape where the sink opening is. You don't even have to create a custom one. It only starts getting custom when you have unusual shapes and curves and things that are not rectangular. Yeah. This piece over here is looking pretty good back in the corner, but it's not quite right. Most of you will recognize that, oh, what happens when you have a countertop and it's up against a wall, especially by a sink? Okay, there's usually another little piece to it that will kind of wrap up the wall. We call it a backsplash. Okay, so if we want to include that, let's show you how you do that. I could model that backsplash in a lot of different ways. I could extrude it from the top, from the flat surface up. I could actually even extrude it like lengthwise. I could go to the end and kind of extrude it lengthwise that way. There's a number of different ways you can do it. And that's the cool thing about all this modeling in place is you can really use whatever method is the easiest for you to define the geometry. You're just creating different solid and negative pieces. So I'll go back to level 1. Zoom on out here. I'll come over here. Now, this is one extrusion. That's cool. I'm going to actually add a second extrusion and get used to this. You often build things up by putting a bunch of different little pieces together. So if I'm going to model that chair, there's like 15 different pieces that are actually all put together. Some are extrusions, some are blends, some are sweeps. It's a lot of different pieces. So I'm going to go through and go to Create, make another extrusion, and I'm going to bring this on down. Actually, I should pick it. Picketing would be a little bit stronger because then it would always stay aligned. Oh, backsplashes are somewhere usually around about 1 inch thick, something like that. Now, again, I need to use my trimming rules, TR for trimming. So I need that continuous loop. Come back over here. Zoom in even closer. TR. Okay, now this piece, we don't want it to go from 2 foot 10.5 to 3. This one, we want to actually have it start at 3 and go a little higher. So how high would a backsplash be? How high would you guess something like that would be? 3 inches? Yeah, 3 inches, 4 inches, it's somewhere in there. There's no set rule about it. So I could have that start at 3 foot 0 and go from 3 foot 3. Oops. Let me finish that up. Show you that in 3D. So now I have that little backsplash on the end. Okay, so we're going to continue this where we're just kind of build up objects. We're going to learn how to build up objects as positive objects. We're going to learn how to build up objects by sort of adding negative things that you can subtract parts away. But almost anything that we model, in fact, this is really how all the Revit parts are created. Everything you go to the Revit library, if you go there and you open and edit it, you'll see everything's made up of these parts that either get extruded or put together. Just right before the break, let me give you sort of the last chunk here about other ways of doing this. Extrusions is probably the most useful way. 90% of what you can do, you can probably get done with extrusions. Okay. There's a couple of other form creation tools you need to know about that are related, though. There's something called a blend. I'll tell you what a blend is real quickly, and we'll play with that next time. A blend is the whole notion that you have one profile at the bottom, and you have a different profile at the top. Okay, so in this case, there's a square at the bottom, there's a square at the top that's rotated, and the blend will take those two profiles, and whatever the difference is, it'll morph between them. Okay, so it just blends the two different shapes. So pyramids, there's a lot of things that are useful to do as blends. If you have two disparate shapes and you need to kind of get them together, it'll take care of that. Another really useful one is something called Revolve. Revolve is you take some sort of profile, you take an axis, and you just spin it around the axis. It's like if you've ever used a lathe or some sort of tool to kind of like spin a surface around something. So this axis and that profile created that whole shape. It would just spin it around, and yeah, that's also very useful. There's a very useful one called a sweep. A sweep is all around the notion that I can take a profile and instead of just extruding it, I can basically have it follow a path. So I can have it follow, it doesn't have to be a straight path, it can be a curved path or some sort of arbitrary path. Where that tends to get used is for things like crown molding, chair moldings. It's things where you have some unusual profile and you want it to go all the way around the room, to follow a curve. Like we make like railings on stairs, the handrail on the stair, we often make that with a sweep because it's really like a circle that just got swept down a path. And if it was a single straight line, then it could be an extrusion. But if it has to follow a path, then it's a sweep. And the last variation on this theme is the swept blend. And what does that do? That's kind of like well, it merges the two. If they got together and had a kid, they would have a swept blend where it's two different profiles that are morphed along the path. Okay, so you don't use that all that often, but there's occasionally times when you want to use that. So those are your big five. Okay, extrusions, revolving, sweeping, blending, and swept blend, something like that. And using those five basic techniques, you can create anything, basically. And that's what we're going to do next time. It's going to learn how to use those to create more custom parts, and then say, okay, I like my custom part so much. What if I actually wanted to add parameters to it so that I can generalize it and share it with other people? Okay, that's where we're going. So let us pause now and go ahead if you want to go take like a 5-minute break, something like that. Just relax for just a second. I'll let my computer crash here for just a second, and we'll do all that. When you come on back, what we're going to do is I'm going to walk you through really quickly how to go through and create some structural elements and show you how they actually get tied into analysis. Okay. Again, something we'll do as we move ahead into the next major design project. So come on back in just a few, and we'll kind of stick around and answer some questions for people.